it's capable of generating a string that is ambiguous. Now, a couple of remarks, sort of not really comments, sort of a bit of extra information that's interesting. Sometimes you can find an equivalent grammar, equivalent in this context. That's new, we haven't done that. So two grammars are equivalent if they both generate the same language. All right? This definition of equivalence, this is our third definition of equivalence. Before, we had two machines, two automata were equivalent by definition if they recognized the same language. Earlier on this board we had equivalence between an automaton and a grammar if, again it revolves around the language, if the language recognized by the automaton is the same language that is generated by the grammar. And now we have equivalence between two grammars. Right? That's new. And, well, it's almost common sense. Two grammars are going to be equivalent if they generate the same language. Okay? Now, sometimes it can happen that you can have a grammar that's ambiguous, but you might be able to find an unambiguous grammar that's equivalent. In other words, it generates the same language. Okay, that's possible sometimes. Hmm? So that might be able to. You might be able to solve your problem that way. I don't know. Maybe you're designing a computer language or something, and you create a grammar for it, and it's ambiguous. Well, you might be able to find an equivalent grammar that's unambiguous, and you need that, right, for computer languages. A computer program has to be interpretable in a unique way. That's important, right? Now, so another comment or remark: some languages, context-free languages, CFLs, they can only be generated by a grammar that is ambiguous. In other words, there are some languages that they have no grammars that can generate them that are not ambiguous. Or saying the same thing again in another way, there are some languages that have no unambiguous grammars. Okay, that can happen. Now, such grammars, joking languages, the languages like that, they're called inherently ambiguous. Inherent, they're just built in. You can't change it. Right? You cannot find an alternative grammar that is unambiguous. That just can't be done. And here's an example. Question 29 in problem section at the end of the chapter, end of chapter 2, problem 2, or 29. You're asked to show, to prove that this language here, A to the I, B to the J, C to the K, where either I and J are equal or J and K are equal, you're asked to show that language, that set of strings, is inherently ambiguous. Meaning that any grammar that generates this language will be ambiguous. Okay, even using leftmost derivation. All right. Okay. Now another new topic. It's called Chomsky normal form. That's the same Chomsky I mentioned a few times already. The famous Chomsky, one of my personal heroes. Not so much on the linguistics side, because I'm not so interested in linguistics, but I'm very interested in political things. I'm the guy who's saying major war is coming over species dominance, So technology and politics interest me very much in the way the two interrelate. So I really enjoy listening to Chomsky's acid political commentary on. He's sharply critical, that guy, of the abuses the American government has committed against the world over a century or more. Right. Okay, so Chomsky normal form, it's used such a lot that it too tends to be abbreviated to just CNF, right? And what is it? It's a way of writing grammars. It's a kind of a convention that you use when creating grammars that simplifies the grammar. So it's a kind of simplification. And basically, well, I'm jumping ahead a little bit because you run out of session, run out of board. But basically the idea is this. On the right hand side of a substitution rule, you just have two variables, right? So say like BC, or you just have one terminal. That's it. Really simple. So and it works. It's you can do whatever you need with this. You can convert. I think it hasn't said so, but anyway, you can write grammars using the CNF, the Chomsky normal form, in this form, where the right hand side of your substitution rule is just two variables, right? Like BC, or one terminal. Well, then a few other minor things like the empty string and so forth. But essentially that's it. Okay. Now, by using the Chomsky normal form, because this is pretty simple, it makes the automation, done by computer. It makes the automation of processing CFGs much easier. So you can get a computer to analyze using algorithms, software algorithms, based on the Chomsky normal form, CNF, that makes the analysis of grammars much easier. Okay, so that's the big plus for computer science people of using the CNF, Chomsky normal form. So we'll continue on with this at the next session on the next board.